Good morning. Today we're going to talk a little bit more about bivariate data. Bivariate data involves two variables. We investigate bivariate data to see what kind of relationships the two variables have. This is used a lot in the real world, especially in science and social studies. So let's look at an example here. Our example is, does studying improve your math score? So as you think about it, what do you think? Does studying improve your math score? Well, Mr. O'Brien, a high school math teacher at KIPP NYC College Prep, wanted to see if there was a relationship between the student scores on the final exam in algebra and the amount of time they spent studying for it. Students studied for the test by doing practice problems on a website that recorded the minutes they spent studying. He recorded the minutes of studying and the test scores in a table. So, as you can see, here's our table. Okay, so he recorded his minutes and the test scores. Here we have our minutes, here we have our test scores. And if you think about it, the minutes directly affected our test scores. We just want to see how, right? So what I'm going to have you do, and I've already done over here, is to graph these points. So we have ordered pairs here. Our minutes studied is going to be our independent variable. So that's going to be along our x-axis. Test scores is going to be y, because your test scores are dependent on how many minutes you study. Right? So I'm going to give you a few minutes. We're going to pause and come back to this, or you can pause the video as you record your points on your graph, and we'll come back to it. Right? Okay, welcome back. Here's my graph. All right, so like I said before, minutes are independent variables, so that's along your x-axis. Time, the test scores is along your y, because that's dependent on the number of minutes that was studied. These are our two different variables, our x and our y. I numbered my graph consistently and evenly. Right, so this was by tens, and my y is by tens, or my test scores were by tens, and I graphed my points. So the first question, and it's already up there, is it says, is there a relationship between the number of minutes studied and the test scores? I'm going to say yes, and I say it's a positive relationship, because as I see the more minutes studied, the higher the test scores, and you can see it. It even looks pretty linear, like I can draw a line right through it. We'll talk about the line of best fit a little bit later on. But there's like one point that doesn't fit or is not doing what the other points are doing. And this would be this point right here. This is the 8638 is that point. It's not quite going with the flow of the other points. And that's called an outlier. All right? And if you look at this graph over here, you can see I have all these points. They seem to be going in a positive direction. As my x increases, my y increases, except these points don't quite go with the flow of everything, and those are called outliers. All right? So right now, we're going to look at some graphs. And we want to see what's happening to our graphs. So here we go. We're going to look at the pattern of association. All right? What kind of association do we see? All right? So for this one, what kind of association do we see with that? Well, what I'm seeing right there is that it's a positive association. As x increases, y increases. So this is a positive association. Okay? A positive association, as one variable, which is x, increases, the other variable does what? Yes, it increases also. That's a positive association. If it's roughly linear, looks pretty linear, and if you could draw a line through it, evenly through it, all the points won't be on it, but I can draw a line right through the middle of those points, the slope would be positive. Examples, height and weight. The taller you are, more than likely, the more you're going to weigh. Smoking and lung cancer. The more I smoke, the higher my chances of lung cancer. Exercise and health. The more I exercise, the better my health. Right? So that's a positive association. Then you have what you call a negative association. So here, I see that as my x increases, my y decreases. That's what's giving me that negative slope. So as one variable increases, which is x, my x is increasing, the other variable decreases. Okay? If roughly linear, if I could get a line, if I could draw a line through that, I would see that the slope would be negative. Examples, the amount you eat and your level of health. The more I eat or stuff or eat the wrong things, my health declines. The amount of money spent and the amount of money you have in the bank. The more I spend, the less more likely that I'm going to have in the bank. That's a negative association. There's an association, but it's negative. And then you have what you consider no association. And if you were to look here at this graph here, I can't really say that it's positive or negative. My points are like all over the place. So it's random without a clear positive or negative relationship, such as temperature and height of kids in class. Does the temperature or the weather determine how tall kids are? I don't think so. And there's lots of other examples. Okay? So that's the association. One more thing that we're going to look at today is we need to determine whether it's linear. So if I can envision drawing a line through it, then it's pretty much linear. So is it linear or non-linear, right? So if I'm looking at this graph here, can you draw a straight line through it? All the points won't be in it, but does it look like it's kind of forming a straight line? Yes. So this would be linear. Now, going back to association. What type of association do you see? As x increases, what's happening to my y? It decreases. So one increases as the other decreases. We talked about that. That's a negative association. Let's look at this one over here. Does it look linear? Does it look like it's a straight line, or is there some kind of curve going on? Absolutely. There's sort of a curve going on. This is not linear. So this would be an example of non-linear. The points are not really making a straight line. What would you say about this one? Right here. No, I see another curve there. This is also an example of a non-linear association. What would you say about this one? Yep, I heard it. Yep, non-linear, not linear. There's a curve. Now, when we're looking at this one, even though it's got this slight little thing there and it comes down, I would say that this is pretty much linear. And the way it's going is going down, so as x increases, y is decreasing. So this would be a negative, linear negative association. There is an association, but it's negative. Okay, what about this scatter plot here? Yeah, there's a lot going on there, but I would still say that this is pretty linear. We've got some outliers here, but this is linear. What kind of association? Absolutely. This is a positive association. Okay, what would you say going on here? There's a cluster. This would be like a cluster. Let's just put that cluster right in here. But this pretty linear. I don't see any kind of curve going on. And I would also say that it has a positive association. And what would you say about this? Do you see any kind of association going on? And if you look at what this one says, and we probably should have looked at the titles on our graphs, this is height to diameter. No, I don't see a relationship at all. So this would be no association at all. It is not linear. Can't even classify it as non-linear. There's just no relationship at all. So, there we go. So, what did we talk about today? We talked about bivariate data. Bivariate data involves two variables. We talked about associations. We said we can have a positive relationship where as one increases, the other increases. Positive relationship like studying in grades. And we talked about negative relationships, or I mean, not relationships, but negative associations. Negative associations is where one increases as the other decreases. A good example of that was the more I eat, the worse my health is, or probably would be, or my health would decline. Then we talked about where we have there's no association. So it's not positive, it's not negative, it's just no relationship at all. Kind of like that example. Does the weather outside determine how tall you are? There's no association at all there. Then we also talked about linear and nonlinear. A linear association, you could envision a line going right through, and that's called the line of best fit, which we'll talk about later. And then we talked about nonlinear, as if you have some sort of a curve going on. So, that ends our lesson today, and we will talk more about data tomorrow.